What's up, guys? It's your favorite math teacher here, and today we're talking about what's called a difference of squares, right? Meaning if you have two things that are squared, and difference means subtraction, so like a squared minus b squared, and so you can actually rewrite that as the quantity, a minus b, times the quantity, a plus b, and so all this is just kind of a faster shortcut. So if you do notice any quadratics that are set up like this, it's a little bit of a faster way to solve it. You'll notice that there is no b value, right? You just have an a and a c. And so in order for this to work, they need to be perfect squares. So let me zoom in on this first one for you, right? X squared is a perfect square because x squared, right? X squared, that's just x times x, right? So a square needs to be the same thing, x squared. Whereas 64, right, is also a square. Square root of 64 is 8 because that's 8 times 8. And then lastly, it needs to be the difference. It is subtraction. So because this is a difference of squares, you don't need to do the whole, right, find the factors of c that add up to b and do that whole thing. You can just look at it and break it up. So since my two values are x and 8 are my squares, I can just factor this out as x minus 8 times x plus 8, right? If you were to distribute this, what's going to happen is your middle term, your b values, are going to cancel out because if my c is negative 64, in order to get 0, I need positive 8 and negative 8 because those make 0, and they multiply to 64. So again, this is just a little bit of a shortcut. If you look at my second example, well, 50 is not a square, and neither is 72. But I can factor out a 2, because if I factor out a 2, 50 divided by 2 is 25, so it's 25x squared, minus 72 divided by 2 is 36. Now you'll see, well, 25 is a square, right? Because 25 is 5 times 5. X squared is a square because that's x times x. And 36 is also a square because that is 6 times 6. So I can actually just factor this one out, right? Don't forget that 2 up front. So I'm going to move my 2, scoot down a little bit. Then, right, I have 5x would be the square of my first term, minus 6. And then I just do the opposite, 5x plus 6. So a difference of squares is just a way to have a shortcut for specific quadratic expressions or equations that you may see.